Greetings to all. In this lecture, we will discuss the stator winding design with an example on full pitch double layer winding. Here, we will see how to select the coil pitch, number of coils, winding diagram in detail and with stubbing and arrow check approach. Let us consider an example 24 slot 3 phase 4 pole double layer winding with full pitch. We can see here 24 slots and with respect to the stator core, and all slots are numbered 1 to 24. So, the winding design procedure will be same to make any type of winding. So, we have to analyze the given data and then define the type of winding, whether it is double layer winding, full pitch winding or short pitch winding, those things. Then calculate the number of turns per phase by utilizing the Faraday's law of voltage equation, and select the copper gauge with respect to the current rating, and then make the coils. After making the coils, let us say it is double layer winding, how many coils will come, either it is 24 or 48. So, 24 coils we are considering, means 24 coils we have to make. After making the 24 coils with respect to the coil pitch, place all coils in a symmetrical manner and connect the coils with an additive polarity by utilizing the stubbing and arrow check approach. By we can follow the arrow direction, based upon that thing we can connect the coils, and verification of magnetic poles with right hand thumb rule principles, and then winding check with respect to the body and with respect to the neutral face to face, is there any short or not, and finally we can bring 6 terminals coming out with respect to the 3 phase machine. If it is M phase machine, 2M number of terminals we have to bring it out to make star and delta connections and test the machine with under the operating conditions. Let us consider the same 24 slot machine, 3 phase 4 pole winding, slots per pole per phase is equals to 2 and coil pitch is equals to 6 slots, and coil sides or layers per each and every slot is nothing but 2. That means each slot we have to place 2 coil sides, and total number of coils is equals to coil sides per slot into total number of slots by 2. It will give 24 coils. That means first we have to make 24 coils in this fashion. We can see the coil here, this is the coil, and the number of slots per pole are coming 6, because it is a 24 slot machine and 4 pole, that will give 6 slots per pole, and phase spread for each and every phase 2 slots we have to accommodate, that is slots per pole per phase is equals to 2, right. Based on that thing, 3 phases, first phase will be 2 slots, second phase will be 2 slots, and third phase will be 2 slots under one particular pole. Now we will place the coils. Before placing the coils, we have to make the like this kind of coils. We can see here I am showing one coil, like this 24 coils we can make it, this is the one. So, each coil, how many number of turns are there as per the given voltage and power ratings, and the wire SWG we have to select based upon the current. For this example, we require 24 coils like this manner. It is a double layer and full pitch winding, right. This coil pitch will be 6 slots. So, after making like this 24 coils, one by one we have to place. Let us say this coil side I will place in slot number 1 with respect to the reference. I am considering the starting point will be slot number 1. So, I will place this coil side first. We can see here. So, the first coil side I am placing in slot number 1. One by one the conductors we have to insert in the slot here, in the empty slots one by one we have to insert here and here. So, the first coil we are inserting in first slot and 7th slot bottom side. Here 7 dash represents 7th slot bottom side we are placing the coil, and without dash x represents the coil side we are placing at the top side of the slot. So, the first coil we are placing slot 1 top side, slot 7 bottom side. Second coil, that is related to the first phase only, because the coil span or coil belt or phase belt is equals to 2 slots. Based upon that thing, second coil we are placing in slot number 2 top side and slot number 8 bottom side. We can see here how we are placing the coils. This is slot number 1 top side, this is slot number 7 bottom side, slot number 2 top side, slot number 8 bottom side. So, like this 2 coils we have placed in the 4 slots. After placing these things, it is a double layer winding. Because of that reason, instead of starting from other phases, we have to follow from the 7th slot, because already bottom side we have filled the conductors. So, it is easy to fill the conductors at the top side. So, here I will place the next coil, that we can see 7th and 8th slot top side we have placed. Like this 2 coils we are placing, one is at 7th slot top side, the other end of the coil is 13th slot bottom side, such that in a sequence we can make the windings. At the end only we have to remove these 2 coil sides and place the conductors at the bottom side of first and second slot, and then again we have to place back the first and second coil sides. Okay. So, in a single layer winding we can come in any fashion, but in a double layer winding first we have to place the bottom side conductors and then we have to place the top side conductors. We can see same manner here, 13th and 14th slot top side and 19th and 20th slot bottom side, 2 coils we have placed. This coil side is placed in 13th slot top side, this coil side is placed on in 19th slot bottom side, that is 19 dash. Same manner another coil also we are inserting in 14th slot top side and 20th slot bottom side. Next we have to fill in this place. So, 19th and 20th slot top side we are placing the coil sides, and first and second slot bottom we have to place. That means already we have placed this 1 and 2, right, top side we have placed the conductors. In order to place the conductors at the bottom sides or coil sides at the bottom, we have to remove this 1 and 2 outside, then we have to place 1 dash and 2 dash first, coils related to the 20th and 19th slot first, then we have to place the coil side related to the 7th slot and 8th slot at the top side. This is 1 and 7 dash, 2 and 8 dash, right. Initially we have placed 1 and 2 as a reference. At the end we have to bring these 2 coils out and then insert these 2 coil sides after placing the bottom side coil sides, that is 1 dash and 2 dash, these 2 things. Similarly for B phase or second phase, 3 and 4 top side, the 2 coils, one coil is placed at the top side of slot 3 and bottom side of slot number 9. Next coil is placed in slot number 4 top side, that is this one, and slot number 10 bottom side. Similarly, the slot number 9th top side and slot number 15 bottom side, same fashion 10 and 16 dash. Here coil pitch is decided based upon the full pitch winding, 1 plus 6 is equals to 7 and for example 9 plus 6 is equals to 15. So, 9th slot top conductor, that is without any dash, is we are placing in the other end is in 15th slot bottom side. So, the remaining coil sides related to the B phase also placed in the machine. We can see these 4 and these 4, all 8 slots are filled with second phase conductors or second phase 8 coils. Next, C phase coils we can see here. First coil related to the C phase is placed in 5th slot top side then 11th slot bottom side. This is the, let us say this is the coil related to the C phase or third phase. So, this starting will be placed in 5th slot and second coil side placed in 11th slot. So, let us say we are placing in at this particular slot means that is 5 and next slot bottom side 11 dash we have to keep, and then from 11th we have to start, okay, top side of the 11th slot, then that complete slot will be filled with coil sides. So, with respect to the A phase we can see here 8 coils. Okay. Earlier for single layer winding we have seen per phase 4 coils. Because of the double layer winding each phase has 8 coils and total number of coils in the machine are 24, that is 24 coils, that means 48 number of terminals are there. This paper's end terminals we can see here in the machine, 48 number of terminals are there in the machine. So, how to connect these 48 terminals? For that we will follow the stubbing method with arrow representation. So, the number of coils per one stubbed winding with respect to double layer winding is equals to slots per pole per phase. The number of stubbed windings for to make the complete machine winding are okay. So, for that MS into slots per pole per phase into pole pairs, that will give 12 stubbed coils we have to make. Even though we have 24 coils in the machine, we will make 12 stubbed windings. These 12 stubbed windings only we will make the connections by utilizing the arrow representation. We can see here one stubbed winding, first coil related to the A phase or first phase with respect to our reference, second coil. So, the first coil is placed in slot 1 top side and slot 7 bottom side, that is this one, and slot 2 top side and slot 8 bottom side. These two coils we are making as one stubbed winding, and it is a virtual representation for these two coils. The starting will be 1 and ending will be 1 dash. Same physical representation, for easy purpose we are representing as one stubbed winding as a virtual manner. So, this stubbed winding starting will be 1 and ending will be 8 dash. Okay, this connection we have to make it with copper. Okay, we have to join the 7 dash coil side end terminal and second slot top side coil side starting terminal. Okay. The ending terminal of first coil and starting terminal of second coil we have to connect. The ending terminal is placed at the bottom side of slot number 7 and starting terminal of second coil is placed in top side of the slot number 2. Next, the stubbed coil with respect to the second phase I am representing with B. Okay. So, the coils which are placed in slot number 3 top side, slot number 9 bottom side, slot number 4 and slot number 10 we are making as one stubbed winding, starting will be 3 and ending will be 10 dash. Okay. Similarly, C phase one stubbed winding I am making, and it is a combination of 2 actual coils we are making connection and we are making as one stubbed winding. So, total 12 stubbed windings we have to make from the 24 coils. 2 coils we are joining each other in this fashion and we are making 2 coils equivalent as one stubbed winding. Okay. So, finally, we have 12 stubbed winding means 24 terminals with 12 stubbed windings. Without stubbing 24 coils and 48 terminals are there. Okay. So, how to connect these 12 stubbed windings and 24 terminals? For that we will follow the arrow check representation. For symmetrical and greater than 3 phase machines, one arrow will be forward and one arrow will be backward direction. For asymmetrical and 2 phase machines, 2 arrows will be forward and 2 arrows will be backward direction, and the number of arrows will vary with respect to the stubbing coils. Let us say 24 stubbed coils are there, 24 arrows, 12 stubbed coils are there, 12 arrows. In this example we have 12 stubbed coils. Each stub winding consists of 2 coils, 2 actual coils related to that particular phase winding. So first stubbed winding I am representing with arrow in this fashion, that is S1, we can see here. Next S2 with respect to the next stubbed winding, here we can see S2. Then S3 with respect to the C phase, these 2 coils, the coil side which is placed in slot number 5 top and slot number 11 bottom side, slot number 6 top side and slot number 12 bottom side. These 2 5 and 11 dash and 6 and 12 dash, these 2 coils we are connecting with external connection and we are making as one stubbed winding. That arrow will be in this fashion, arrow will be forward, one arrow forward, one arrow backward and again one arrow forward, same fashion, one is forward backward. Like this fashion we can represent 12 arrows. Each and every place we can see S1 is forward direction, S2 will be backward direction, like that manner. By utilizing these arrows we will connect the stubbed windings to make the symmetrical 3 phase winding. These are the 4 poles. Let us consider first 6 slots are forming one pole and next 6 slots are forming second pole. Like that 6 slots, the conductors related to excited currents, it is forming the 4 poles, that we have to verify after making the winding connections. Let us consider the stubbed windings related to the A phase, or 4 windings are there. We can see here this is 7 or sorry first and 8 dash, then 7 and 14 dash and 13 and 28 dash, 19 and 2 dash. So this is the actual winding and we are representing as a virtual manner one stubbed winding, but that stubbed winding has the terminals information same as the physical winding. We will follow this arrow check approach to make the connections. We have to walk through the along the arrow direction. Let us say this arrow is in this direction, next arrow is in this direction, right. We have to follow this head to this tile, next arrow tile. Not only this S1 to S4, S1 to S7 or S1 to S10 also we can connect. We can see the first connection, S1 arrow head is this one in this fashion and S4 arrow head is in this direction. So this connection we are making now. And next thing, with respect to the S7, S4 head is connected to the S7 tile point. The same thing we can see, S4 arrow head point is this one, then S7 arrow is like this fashion, this is the tile point. So this is the head point of S4, so we are connecting this connection. Same fashion we have to follow the arrows, only 4 arrows are there with respect to the A phase, S1, S4, S7 and S10. So with respect to this arrow in this direction, S4 will be in this fashion, S7 is like this, S7 is in this manner. So we are just following the arrows. So this is starting of A and this is ending of A. Okay, that 4 arrows we can see here, that particular connections. This is starting of A phase and this is ending of A phase. Same manner we can connect the B phase and C phase connections. This is B and this is C. Let us say I am starting from this arrow and next arrow is like this. So this head point I am connecting here and tile point we have connected. This head I am following the next arrow tile, then next arrow head I am connecting to the next arrow tile in this fashion we can connect. So, we are just following the arrow direction to make the winding connections. So, these connections we have to make with copper, like we can make the soldering to make the rigid connection between the two coils. So, with respect to the terminal, let us say this is some number x, this is some number y. So, these two terminals we have to connect with copper with soldering, proper soldering. This is C phase. Here also same manner, I am considering this is starting point S3, same arrows, one will be forward, one will be backward. So, here with respect to the arrow representation we will connect the coils. Okay. So, from this point head we are connecting to the tail, these 2 points, and then from this point head to connected to this tail point, and from here to here, and then as per the arrow we are coming out with the connections, this is C dash. So, the final 3 phase connections we can see in this fashion, all these 3 phase things. This is at 0 degrees, B phase at 120 degrees with respect to 2 poles, C phase at 240 degrees, or I can say B phase at 240 degrees, C phase at 120 degrees. We have to change the representation, that is it, as per the physical winding displacement. All 3 windings are displaced by 120 degrees, depends upon the phase sequence, it will rotate either clockwise or anti-clockwise, that we have to verify, and then we can change this terminal as B and this terminal as C if requires. And we will discuss now how to make the stubbing. Each stubbed winding consists of 2 coils, right. In method 1 we are making the stubbing after placing the all coils inside the machine. Let us say these are the 4 terminals we have placed inside the machine, these 2 coils, and we are making this connection after placing all coils. Okay. So, stubbing is done after placing all coils, that is method 1, whereas the method 2 and method 3 the stubbing we will do before placing the coils inside the machine. Let us take this is coil 1 and this is coil 2, which has to be placed in slot number 1 top side, slot number 7 bottom side, same fashion other slots. So, these 2 coils outside we will connect in series, and then 2 terminals only we will take. That means stubbing we are doing before placing the windings. Here coil pitch is same in both coil 6 and 6, whereas in the method 3 the coil pitch with respect to the outer coil side is 7, with respect to the inner coil sides is 5. So, one coil will be over pitched, other coil will be short pitched, but the resultant pitch 7 plus 5 by 2 will be 6. The copper will be same in all 3 type of stubbing approaches to minimize the connections. So, without after placing the windings, this connection we have to do externally. By following stubbing method 2 and stubbing method 3, the connections will be minimized, the number of terminals to connect will be minimized, where the stubbed winding consists of only one coil, which is a representation of coil 1 and coil 2. Based on that thing we can connect the different windings. With this I am concluding this lecture. In this lecture we have discussed the winding design with respect to double layer full pitch winding, how to make the connections and how to develop the winding diagram, etc. Thank you.